Good morning, everyone. I'm Brock. So today, let's solve another LeetCode quiz again. Let's get a random question. This is a hard quiz, so let's skip this one. This is a medium. Okay, let's work on it. So the question is maximum number of non-overlapping subarrays with sub-equals target. Our goal is to, given an array names and an integer target, return the maximum number of non-empty, non-overlapping subarrays, such that the sum of values in each subarray is equal to target. Here is a test case. So the input nums is 1, 1, 1, 1, 1. There are 5 1 in the list. And target is 2. So there are 2 overlapping subarrays. 1, 1, and 1, 1, with sum equals to target 2. Right? The maximum number of non-empty, non-overlapping subarray. And each subarray sum is equal to target. Okay, I guess I have some sense what's the question. Again, so let's look at the key strategy maybe we want to utilize. So first thing, I think that we need to use a prefix sum and a site to track sums seen so far. Right? Because we need to calculate the sum of the subarrays. So we need to calculate it first. Then when we find the current prefix sum minus target is in the site, a non-overlapping subarray is found. And the next step is that reset the set after finding a subarray to ensure non-overlapping. Right, there are 2 key points. One key point is that the sum is equal to the target. The second key point is that there's no overlapping in different subarrays. So the input is a list of integer and an integer, and our return is a integer. So let's initialize several index first. Count is 0. Prefix is 0. And initialize a set. It's also full of 0. Okay? So what we need to do here is we need to traversome the whole names, right? So for the name in names, right? Update the prefix sum. So we go through each elements in the original array. And then if we find the prefix sum in same, which means that we found a vanished submarine, right? I think this is easier to understand. Then we need to recite when non-overlapping. And also that we should put this sign in the same. If the sum is not equal to the target, then we just add the prefix in the sum. at the end, what we are looking for is how many such sets we have found. Right, so the basic idea is to use greedy prefix sum recite, ensures no overlapping. Let's try to run it first. Vanity index okay. Yeah, so this is a very stupid error. The plus and equal must be together. Between them, there shouldn't be any space. Okay, I try to submit it. Okay, it passed. And again, let's try to explain the building functions, building methods, step by step, edge test case for the algorithm. Okay, so I think that we can use ChatGPT to explain, some tricks we do here. So firstly, this is some basic building functions or methods in Python. First one is site. It will create an empty site. It's an ordered connection of unique elements. Let's say 1, 2, 3, 3 to 1, right? They are actually the same site. And the site 0 means we initialize the site containing 0. Here it means the prefix site starts as 0. And you can see here, because we don't know how many sites we will find, right? So we need them to define how long, how many elements in the site. And at X, this method, this building site method adds element X to the site. Duplicate values are ignored automatically. So for example, if we get a site like 1, 2, 3, and we add 1 again, because 1 already exists in the site 1, 2, 3, then add 1 will be ignored, right? Because inside it must be unique elements and it's unordered, right? But if we add 4, then 4 will be added into original sites. In just an operator check if an element exists in a container, return true or false. And the plus equal will add a value to a variable and updates it. This is also something I think that we learn in the first year in undergraduate. Return the results of the function. For long in lumps, it's building iterator mechanism. It will loops over each element in list lambs. And let's get a step-by-step example. Yeah. So let's say this is edge case. Okay, so here is an edge case example. So the lumps has 4 elements, 1, 1, 1, 1, and the target is 2, right? So the first step, we will add 1 into same. So the number is 1, and the prefix sum is 1. And we don't see it before. And the prefix sum minus target is -1, which is not 0, right? So because it's not 0, so we need to keep, going on, which is not found. The count is still 0. And the next step, the second element in the lumps is still 1. And now the prefix sum is 2, right? Because we added with the previous pre-sum. And now the site symbol for will be 0, 1. And then now the prefix sum minus target will be 0, which means we find it, right? We find the subarray which align with the targets. So the counter will become 1. And step 3, we go to the third element in the list. It's 1. And the pre-sum is 1 again, right? Because we recite prefix sum every time we find a subarray. Same before? No. And the prefix sum minus target is -1, which means we haven't found it yet, right? So the counter is still 1. And step 4, this is the last element in the list. It's 1. Prefix sum is 2, right? Because again, we add the current element with previous element. And we've seen it before. So the subsite is 0, 1. And the prefix sum minus target is 0, which means we find this element. So the count is 2. I think this is pretty straightforward, right? And also we can quickly look at the code all walkthrough. So this part is that we will define count for total number of valid springs found. And the prefix sum is a calculative sum we traverse. And we will use this value to compare with our target. And the same starts with 0, because before any element, the sum is 0. This is what we will use to store the subarrays. And this part is to update running prefix sum as we can scan through each number. We'll keep add the new elements into the site. And this block of code is to check if there's a previous prefix sum that satisfies the equation. Right? The basic idea is to see whether the current sum minus previous sum is equal to target. And the submarine sum from previous plus 1 to current is equal to target. And once found, we will reset prefix sum and the same to ensure no overlapping. And if not match, we call this prefix sum for future comparison. Right? I think that is the example here demonstrate, right? Where the prefix sum minus target is equal to 1. Is equal to 0. But I think that here we can just directly say if, right, if prefix sum minus target is equal to 0, right? Let's see where this work. Okay, this doesn't work. Let's see why. Okay, so the original logic, if prefix sum minus target, insane, means have I seen an earlier prefix sum such that the subring between that earlier index and the current index sums to target. But if when we check if prefix sum minus target is equal to 0, this means if pre-sum is equal to target, means the subring from index 0 to current index sums to target. This ignore all other possible springs that start in the middle. Here's an example. Okay, so if we use the wrong logic, right? So again, in the test case, the nums is 1, 1, 1, 1. There are 4 1 in the list, and the target is 2. And the wrong logic, step 1, num is 1, prefix sum is 1. Because we will check if prefix sum minus target is 0, and obviously it's minus 1, so it's no. Okay, this is not a good example. Let's try a more general case. So ChatGPT gave a more general case. The list is 3, 4, minus 7, 1, 3, 3, 1, minus 4, and target is 7. So the wrong logic will output 1 because this version only detects prefix sum is equal to target 7. But miss prefix sum is equal to 11 and earlier prefix is equal to 4. And 11 minus 4 is equal to 7. Okay, so I guess that the key point we need to pay attention to here is our original definition. For prefix sum, right? What we want to do is prefix sum. We will calculate the sum as we traverse. But every time when we find a subring, we will actually recite prefix sum. Let me see whether we can make ChatGPT use some visualized way to demonstrate. So it's still confusing because I think we already reset prefix sum every time we found a subring. Can you use some visualized way to demonstrate the logic? Okay, so when we ask it to create something visualized, it still actually output in a text version. But anyway, let's see whether this time it explain this point much clearly. So the first question is, what are we trying to detect? We want non-overlapping subarrays whose sum equals to target. To detect an array sum is equal to target, we rely on prefix sums. Imagine the cumulative sum prefix at each index. So in this example, for index 1, the prefix is 3. Index 1, prefix is 7. Index 2, prefix is 0, so on and so forth. So if we subtract 2 prefix and get 7, then the element between those two indices from a subarray summing to 7. That's straightforward, right? And the second point we need to figure out is why just checking prefix sum equals to targets is not enough. The original character code will check if any previous prefix leads to an array equals to target. But the wrong code only checks if the entire prefix so far sums to target. And again, it's a table to explain. Let's directly look at the wrong situation. So if we are checking if prefix sum is equal to target, okay, so the first time prefix is 3, right? And because the prefix is not equal to target 7, so not found. And then we keep going. We find the number 4. The prefix sum is 7. Then we find it, right? We find a subring 3, 4. And we recite. And this time we get -7. The prefix is -7. It's not equal to target. Find nothing. And then prefix sum is -6, -3, 0, 1, -3. So in this way, we only find the subring 3, 4, but miss the subring 1, 3, 3. Why? Because the second valid array starts in the middle, and its cumulative prefix sum 0 to 7 can only be detected only when we remember earlier prefix sums. 0, -7, -3, etc. Right? If we only check 7, then it doesn't work. But if we find -7, so how can we find 1, 3, 3? To find 1, 3, 3. So if we look at the character logic, right? We find 1, 3, 3. Because we find -1 is in the site. What does that mean? Right? It means that the prefix sum minus target equals to something happen again, which means that current sum, for example, current sum is -7, right? Minus previous the pre-sum. Is equal to the target 7. So current sum is actually so if you look at it, we set here and we calculate them together. So the current prefix sum is 0, right? And we find previously we have -7, which means that in between there must be a 7 exists, correct? So that's the key trick of this algorithm. I think now it's much clear. I guess that the most tricky. Sometimes I think the most tricky part is to find the edge cases in the algorithm, because if we cannot find the edge cases, it's very easy, to oversimplify the question and then make some errors. Well, that's it. Thank you.